Okay, now let's look at this. The question say that rectangle DEFG is similar with rectangle EKLD. Okay, now first let's draw DEFG. DEFG. Okay, EF is actually 2.4 plus 12.6, give you 15 cm. Okay, now we're going to draw the second triangle, but make sure you follow the same position. That means if you have DE, okay, then you must have the corresponding length EK. So if you draw DE here, your EK must be here. Okay, then your EF, the corresponding length is KL. Okay, so similarly, if FG, it must be LD. Okay, then you got DG, GD must be same as DE. So we align it so that they are at the corresponding length. That means this length corresponds with this length. This length corresponding with this length. Okay, now then KE is 2.4. Okay, now question asked is what is the length of DE, which is this one. Let's let DE equal to Y. Okay, DE equal to Y. This is what the question want to know now. Okay, now since they are both similar, we're going to use scale factor. Okay, scale factor. Now, should we use the big one over the small one or the small one over the big one? Let's look at the second question. You say that the area of EK, you want the ratio of EKLD, which is this, over the area of D. That means the scale factor, we're going to define it as, so this is a small one, so it's the smaller length over the bigger length. Okay, the smaller length, that means this over this and this over this. Now let's do the first scale factor. We want the smaller one. This is smaller one over the big one. So the smaller one is 2.4, which is, let's write down, is EK. Remember, must follow the pattern the way you name it. EK must be, the corresponding line must be DE. So it's DE. Okay, now let's put in the value. This is 2.4. DE is Y. Okay, similarly, scale factor also can be defined as this length KL over EF. So it's Y, the shorter length, over the bigger length, which is EF. Okay, therefore Y is over 15. Now, if this similar triangle, this and this similar, their scale factor are the same when you compare the corresponding length. So therefore, this scale factor and this scale factor is the same. In other words, we take this scale factor 2.4 over Y. We're going to put it here, 2.4 over Y. It must be equal to this scale factor, which is Y over 15. Okay, now, so let's cross multiply. Y times Y become Y square. Okay, now, then 2.4 times 15. Okay, now, so it's actually equal to 36. So Y actually becomes square root of 36, which gives you 6. In other words, this value DE, this one DE is actually equal to 36 cm. In this case, the unit is cm. So Y is actually DE. Therefore, DE is equal to 6 cm. Okay, now let's talk about comparing the area. You know that if you compare the area, the ratio must be equal to scale factor square. Okay, now let's go back how we define the square. The scale factor is the smaller one over the bigger one. So therefore, area of the smaller rectangle, which is EKLD, over the area of DEFG. This is equal to scale factor. Remember, comparing area is square of the scale factor. Okay, now scale factor earlier we defined at 2.4 over y. Since we have already find the value of y, so we just use this. So it's 2.4 over 6, and then you square it. Okay, so now simplify whatever the base, let's divide by 6. So this one divide by 6, you got 0.4. 6 divided by 6, you get a 1. So as a result, this is 1. So it's actually 0.4 square. Then it's actually 0. If you multiply 0.4 times 0.16. Okay. So that's it. First, you rearrange the triangle based on these two triangles. And remember, it's always follow the pattern. If you DE on the larger triangle, then it must be EK. DE must be EK. So we rearrange this one, rearrange it so that it's in the same position. This one correspond with this. This one correspond with this. Okay. Now after that, you establish the scale factor based on this and this. KL and DE, they are the same length. ED and KL is the same length. So if I define DE as y, KL end up at y. Okay? So now, so after you have defined all this, now scale factor we are looking at EK over DE. EK over, because these are the corresponding lengths. So EK is 2.4, DE we define as y, we put y. Similarly, we also define the scale factor as this over this. Y over EF. EF is actually addition of 2.4 and 12.6 with 15. Now, if these two triangles are similar, the scale factor has to be the same. So this scale factor we're going to take from here, which is 2.4 over y. So this y over 15. So they are equal since they are similar. So from here you cross multiply, you got a y, the value of y. Therefore DE is equal to 6. Then if you want to compare area, it's actually scale factor square. The question asks for the small one over the big one. So EKLD over DEFG. Okay, so the scale factor is the small one over the big one. 2.4 over the big one is y. So you square it, you get 0.4. So you square 0.4, you get 0.16. So that's it.